Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. For many decades, the standard cosmological model has stated that the universe began many billions of years ago with a primordial explosion called the Big Bang. Beginning from an unimaginably hot, dense point, material rushed outward at nearly the speed of light, and to this day the physical expansion of the universe is thought to continue. When scientists found evidence for the apparent acceleration of the expansion rate of the universe, the hypothetical influence of dark energy was invented. For a scientific hypothesis to be testable, it must make predictions. And the technological data available to test the Big Bang hypothesis has never been finer. For over 5 years on this series, we have reported on numerous theory-shattering discoveries that challenge the very underpinnings of the Big Bang. From impossibly huge structures that exceed the size limits for any object at this time in the Big Bang universe, to so-called ancient stars whose chemical composition is completely wrong if they formed from material in the early universe, to grand design galaxies that display a complexity of form that defy their theoretical age, to evidence that the so-called expansion of the universe is accelerating at an impossibly fast rate, even accounting for dark energy's influence. Many scientists have acknowledged the major problems these discoveries pose for Big Bang cosmology. Nevertheless, consensus scientific opinion remains that the Big Bang is the best current theory for the origins of our universe. Indeed, a recent Scientific American article aroused a response from some of the world's most revered cosmologists that demonstrates just how slow and difficult is real change in the culture of science. The article in question, entitled "Cosmic Inflation Theory Faces Challenges," proposed that the universe began with a so-called Big Bounce instead of a Big Bang. The authors question cosmologists' interpretations of measurements of the so-called cosmic microwave background. Specifically, they disagree with the interpretation that data first published in 2013 proves that an extremely fast inflation occurred after a Big Bang 13.7 billion years ago. They state, if anything, the Planck data disfavored the simplest inflation models and exacerbated long-standing foundational problems with the theory, providing new reasons to consider competing ideas about the origin and evolution of the universe. Yet even now, the cosmology community has not taken a cold, honest look at the Big Bang inflationary theory, or paid significant attention to critics who question whether inflation happened. In a response letter to the controversial article, 33 scientists, including physicist Stephen Hawking, begin with a statement: "There is no disputing the fact that inflation has become the dominant paradigm in cosmology." They then accuse the authors of, quote, dismissing the research of not only all the authors of this letter, but also that of a substantial contingent of the scientific community. However, the problems for Big Bang cosmology reach far beyond anything that Hawking and his colleagues seem ready to acknowledge. On the question of the so-called cosmic microwave background, or CMB, the conclusion that the radiation is a, quote, background at all begins with the assumption of a Big Bang. But as previously discussed on this series, ample evidence exists to consider that the, quote, asymmetric radiation is in fact a locally produced foreground. As physicist Wal Thornhill has explained, proponents of the electric universe and plasma cosmology argue that the radiation is due to microwave radiation from the filamentary galactic electric currents flowing in the neighborhood of the Sun. In fact, some of the expected structures, a galaxy-wide sample of dense filamentary structures correlated with spiral arms and star formation, have been recently mapped. The image on your screen is an example of a network of galactic filaments. As Thornhill notes, we see a roughly orthogonal branching of tributaries, which is characteristic of an electrical discharge. This principle is seen in this comparison with experimental discharge filaments. If the CMB is in fact what physicist Eric Lerner has described as a, quote, radio fog of dense plasma filaments, its presence tells us nothing about the age of the universe. The local origins of the radiation would also help explain the seemingly baffling discovery of apparently vast and remote cosmic voids. The appearance of a cold spot, where the, quote, temperature of an area of space is interpreted as significantly lower than the surrounding region, suggests the presence of a void where many galaxies should be observed. The interpretation of the size of the so-called void is based on the assumption that the redshift of the surrounding galaxies provides an accurate measure of the object's size and distance. In recent years, some scientists have offered the incredible speculation that such a void is actually the imprint of a parallel universe. In fact, the concept of parallel universes, or the multiverse, is a theory championed by the aforementioned Stephen Hawking, as well as Brian Greene, Michio Kaku, and the current host of the television show Cosmos, Neil deGrasse Tyson. Ironically, at the time that cosmologist Carl Sagan wrote his iconic book, Cosmos, challenges to the very foundations of the Big Bang were still permitted. On the question of whether the Doppler interpretation of galactic redshift is a reliable indicator of an expanding universe, Sagan wrote, "There is nevertheless a nagging suspicion among some astronomers that all may not be right with the deduction from the redshift of galaxies via the Doppler effect that the universe is expanding. The astronomer Halton Arp has found enigmatic and disturbing cases where a galaxy and a quasar, or a pair of galaxies that are in apparent physical association, have very different redshifts." Sagan continues, "If Arp is right, the exotic mechanisms proposed to explain the energy source of distant quasars, supernova chain reactions, supermassive black holes and the like, would prove unnecessary. Quasars need not then be very distant, but some other exotic mechanism will be required to explain the redshift. In either case, something very strange is going on in the depths of space." At the other end of the spectrum from so-called vast cosmic voids are objects that appear impossibly huge. One such object, the quasar cluster Huge LQG, is supposedly so enormous it would comprise about 5% of the visible universe. As one astronomer said of the discovery, it, quote, "upsets the foundation of everything we do." The force of gravity is weak and takes time to move things around. The elapsed time since the conjectured Big Bang sets a limit on how big any structure can be. Structures exceeding that limit are, by the cosmologist's own admission, impossible. One possible solution to this enigma is that the objects simply are not as distant and huge as they appear, based on their measured redshift. Halton Arp proposed that the redshift of quasars depends not only on a velocity value, but also its, quote, "intrinsic redshift." This would be a property of matter that is subject to change over time. Arp found that the intrinsic redshift of a quasar or galaxy took discrete values, which decreased with distance from a central active galaxy. In Arp's hypothesis, many mature galaxies of a specific type eject newborn objects, called QSOs or quasars, and these objects grow up to be companion galaxies of their parents. As they move away from the parent, their mass and brilliance changes, their velocity slows, and they tend to begin to fall back toward the parent galaxy. Proponents of the electric universe, including physicist and chief science advisor to the Thunderbolts project Wal Thornhill, agree with Arp's thesis of quasar ejection. However, Thornhill disagrees with Arp's description of the mass of quasars increasing with time. Arp proposed that the existence of a new quasar becomes recognized by matter in the rest of the universe at the speed of light. But in Thornhill's view, an initially positively charged quasar is followed by a beam of electrons from its parent galaxy, which would explain both the quantized redshift and increase in mass. These electrons may come in bursts, like the quasar ejections themselves, which, if true, would predict and explain seemingly impossibly sudden changes in quasars. As we reported last year on this series, many recently discovered objects in space lend great credence to this thesis. A team of astronomers using the Sloan Digital Sky survey observed quasars behaving in a manner that completely upends conventional theory. Using images from the Pan-STARRS survey, the scientists identified 1,000 objects that appeared to vary in brightness over a period of just 10 years. Among these objects were a total of 5 galaxies that the team witnessed shape-shifting into quasars in a seemingly impossibly short period of time. The team also recorded a total of a dozen quasars, quote, shutting down in a period of hundreds of days, rather than the hundreds of thousands of years required by standard theory. As reported by NewScientist.com, astronomers expect quasars to use up their fuel and settle down into quiet galaxies, a process that should take hundreds of thousands of years. So last year, when a dozen quasars were spotted shutting down in just hundreds of days, it was a shock. In subsequent decades, as demonstrated by the recent protests of Hawking and company, little has changed in the culture of science. The seemingly endless cosmic surprises have yet to force any real reassessment of the cherished 13.5 billion year, quote, history of the universe. Institutional science remains unready to confront the possibility that based on our current limited knowledge, we must accept a universe of unknown age and extent. So the surprises for cosmologists will only continue, since nature seems to have no regard for human beliefs. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.